Yeah, hi, good evening, everyone. So, welcome to the open session for next week. So, this week 9 actually is now running. So, I hope you have done week 8 and now you are doing week 9. So, any specific query before starting the session? Any question? Anyone?
Excuse me,
Yes, yes, Ahmad.
regarding the OPP scores, have they been released yet or are they still in process?
So actually, scores the things are still in process. So maybe you will get these score by this weekend. Okay.
And the time lab assignments that we are submitting, are they also getting evaluated at some?
Yeah, they all are actually evaluated, but they will be released later. That final score will be released later. Okay, but you can simply calculate it your score. If you are submitting the assignment, if all private test cases are passed, that means you are getting 100% for that. Okay, so
Okay,
but all these assignments score will be released later after completion of the all timed assignment.
okay, thank you.
Okay, yeah,
Hello.
yeah,
So can you hear me?
yes, yes.
Yeah, sir. I wrote the first qualifier. I actually got qualified in that.
Mhm.
Now, is it necessary that I should write the second qualifier also?
No, if you have already qualified, then there is no need to give the qualifier again. So this is only for those who have failed in the first qualifier exam. So this is reattempt basically.
Okay, okay. Thank you,
Okay.
sir.
So have you enrolled in any course after qualifying?
Yeah, sir.
Which course?
They asked me to select any subjects, so I chose three subjects in that.
Okay, okay. So that quiz two actually you have to give the exam. So C programming actually doesn't have this quiz two,
Okay,
but maybe other course you can just see. Okay, so maybe quiz two exam you have to give.
okay, sir.
Hmm.
Good, thank you, sir.
Yeah. So for C programming, we have quiz one, after that OPP one, then OPP two, then final term exam. Okay. So,
Okay.
yeah. Okay. Any other query? Okay. Okay. So OPP two syllabus will be till week 10. Sir, in my dashboard, OPP1 marks is not showing. Yeah, I've been, actually, the score things are still under process. Okay, so ops team are working on that. You will get the score soon. Okay, just wait for some time. Okay, okay. Then if there is no general query or any specific query, then we can start the summary of week 9 basically, and we will also just quickly revise the week 8 because week 9 concepts are that week 8 is required for week 9 also. So yeah, I'm sharing my screen. Okay. Okay, so quickly just revise the week 8, that C concepts, what we have done in week 8, and then we will.
Excuse me, sir.
Yes,
Sir, I want to ask the GRP 3 and GRP 5 of week 7.
week 7.
Yes, sir.
Okay, 1 second. Week 7 and GRPA 3 and
5, sir.
okay. Hmm. Write a function find intersection that takes no non two non-empty integer array AR1 AR2, and the size of these array size 1 and size 2 is parameter. The function returns the number of common elements in AR1 and AR2. Okay. So, okay, return the number of common elements we are finding out. So consider that the elements in each of the area are distinct. Okay. So, yeah, what is your doubt in this? Have you tried this, or you're facing some problem in this?
Sir, I tried it, but every time it failed.
Okay. So, what is the deadline? Deadline is already passed. So now you can see solution also here on the tab. Okay, solution is there. But okay, so let me discuss the solution. Have you seen this solution? And what code you have written? If you can share that, so we will figure out your code, what mistake you did. Uh, am I audible?
Yes, sir.
Okay. So I'm explaining the logic of the question. Okay, so I'm taking this input and
Yes, sir, you are audible, but now I'm using my phone, so screen will sharing is so quite
okay,
trouble.
okay. Actually, solution is already given. So I can check your code if what mistake you did. So otherwise, I'll discuss the logic and solution. Okay. So this is the test case. So you have two array. Okay, and size is also given in the input. So that means first size is 5. Okay, and that means you have 5 element in the first array, and like this 1 2 3 4 5. Okay, and second array you have same 5 element, and 2 4 5 7 8. Okay, so suppose this is a array and this is b, and indexing we have 0 1 2 3 4 on the both. This input is given. Okay, and in the problem statement all these array are passed to the function. Okay, so you can see we the array is already created in the suffix code, this part, and second array is also created. After that all these array are passed to the function. So arr1, arr2, n1 and n2. So all these value are passed. N1 and n2 are representing the size of the both array. And after you need to just create the function for this. So you need to create this find intersection function and just receive these two array, and just read the count number of elements which are common in the both array. So what you can do, you have the both information. You have this first array, second array, and you have the size also. So n1 equal to 5, n2 equal to 5. What you can do, you can just take this array. So you can take nested for loop. So just read for an integer I. Okay, so you can I, that's first loop we are taking for the first array. Okay, and inside this we will start from 0 index, and size of the first array is that n1. Okay, so we will take this I is less than equal to n1. This is size, so we will take n minus 1 equal to. Okay, because indexing is starting from 0, so it will move to till 5 minus 1, and then I plus plus. So this is the first loop, and this loop we are using for to traverse the element of first array. After inserting this loop, and that means what we will do, we will just read the first value from the first array, and then we will traverse the complete second array. Okay, we'll traverse the complete second array and we will match this value. So if this value is matched with any element of the b, so that means this element is common in the both list, both array. So then we will increment our counter. So we will take one count. So count equal to 0 we will initially set, and after that we will so run a loop. So like this for and int j. Okay, and j we will start from the same 0 index, and this j loop is for second and this b array, and j will move less than n2 minus 1, 2 minus 1, and j plus plus. Okay, plus. So this is also j, and inside this loop we will check if our ai. Okay, so this a value, so that means a of I, this I index value is equal to b of j. Okay, if this condition is true, then we will increment our counter by 1. Okay, and this loop will end, and the final loop will end. So this is the nested loop required. So what we will do, we will just check, read the first element, and we will traverse all elements. So if this element is matched with any element, we will increment our counter. Okay, so you can see one is not exist, so that means this loop will run without incrementing the counter. Then we will after exit from the nested loop, then we will increment this I value, then I will become one index, so that means this second element. Now 2 is matched with any element, yes. Okay, so now 2 is matched, so we will increment our counter by 1. So that means c equal to that our count, that means we found 2 common, so one element. This is not one time. Okay, and then we will just read this 3, 3 is not exist, then we will read this 4, and 4 we will traverse, and 4 is matched with this element, so again we will increment our counter by 1. Then we will just check this 5, so 5 is also matched here, so that it will increment one more time. So finally, by this two nested loop, your counter will reach to the 3 value, and that this will be the output for this problem. So if you can see the solution, so 3 is the output, and solution is this is the same. You can see. Okay, so we are taking one counter, and first loop we are just using for the first array. Okay, ARR1, and inside this loop, second loop we are taking for ARR2, second array, and inside this loop we are checking if array one ith element, okay, is equal to array two jth element. Then we are incrementing our counter, and after completion of this nested loop, we are just returning the count value. So this is our answer. Okay. Is
Yes, sir.
okay, so let's move to GRP5. Okay, so this is related to the strings. Okay, so what it is? Hmm. Write a function prints word that takes a string and delimiter as input, and print the parts of the string that are split by the delimiter on separate lines. Okay, so hint, use the strtok function from the string.h library. Okay, this is the hint. Okay, what is the sample input? So sample input is this one. So this string is given, and this delimiter is given second, and you need to just separate this all words in the each line. So hello world, this, age, and then C programming. Okay, and here this okay, so suffix you need to just string, this is the string, and this is the del name. Okay, delimiter, this is the single. Okay. And what are the test case for this? Okay, so 3, 4, 5. So here a hint is given that you can use this str, this toke, that str toke function for string library.h. So let me just open this 1 second. So exact str function, I have to also check that what is this function. 1 second, give me that. This is week 7. Okay, so week 7 array and strings. Okay, so week 7 string, we have this function scanf, fcats, printf, put s, strlen, strcopy, strcat, here, strtalk. Yeah, this is the function hint is given. Okay. This is the one way to you can use this strtalk function. So care, this is the same problem you can see. Here delimiter is given, str is given. So this line is given, and you can apply this token. Or let me try with any another easy method. So this is an array, and we can print this. Okay, let me try this by any another method. So one second. This is a string. I'm taking one example. Okay, suppose we have this. Suppose, and this is the delimiter. All what is given in the problem. This is tier delimiter. This both are the array, and this is the size. Mhm. So one thing what we can do, because this str is an array, okay, and so we can start reading the character one by one, and we can also at the same time we can print that. Okay, but if any time if ever that delimiter is actually occur, okay, so this delimiter is occur, what you can do, you can just print a that new line, you can just move to the new line character. So like this, we can check the length of this. So what is the size? So like int and equal to then size of, and this is a string. Okay, that str, or we can also use this string str. So has include string.h, and inside it there is a method strlen, strlen, and this we are printing. Okay, so let's just check this, we are getting the correct length or not. So printf and %ld, and here just print this value n. So
Why
let's
this
run this.
string.h header file used for any array, na, sir? For array, na?
Not array, this is for string, and we are using this strlen function.
So string and array are different, na, sir? Please explain, sir.
String, actually this is a library which provides some function related to the to handle the string. Okay, but string we can implement through the array. Okay, array is a data structure that contain the same type of elements, and same that string we are also handling by the array concept actually. Okay, we are using the array internally, but that string library actually contains some direct function that applied on this string array, and that returns some value directly. Okay, so some ready-made
Sir,
functions are there
actually,
inside this.
sir, I am confused about the string and array, sir.
No, no. String actually in other programming language we have the another data structure string separately, but in C actually we have the char data type. Okay, so char means we can store only one character. Now, if we want to store string, so string is just a collection of set of characters. So we can represent the string with the help of array itself. Okay, so here in C we are just representing our string with the help of array. Okay, but this string is a library which contain function related to the strings operation, so like concatenation, yeah, length of the string, but our representation of the string is actually happened by with the help of array. Okay, so this is also, you can see this is a array, actually this is a an character array. You can see we are using char, this is an character array. Okay, so do not these are two strings. You're confusing with the name, but implementation is actually happened by the both that array data structure. So array is just a data structure provided by the C, but string is also implemented by array. Okay,
Sir, in foundation, how many weeks of C programming do we have?
11.
Thank you, sir.
Okay, so you can see we are getting the size of the array 26. Okay, so that this by this function strlen, this provides the size of the that string. After that, we just use this length, so like this, and for okay, so we can take the so array have the index start from 0, so we can take I equal to 0, and then I is less than equal to same that is n, okay, n minus 1, and after that I plus plus. So we are traversing this array. What is this? Sorry. So we are traversing this array one by one, and after that we will print here. So what we will do, we will check the condition if our array element, so str that I, okay, so this character is equal to that our delimiter. Okay, so that del m, and this is the only one element we have in the string, so that means 0. If this is matched, and then we will just write a print statement, printf, using the slash n new line. Otherwise we will just print the character, so if not if else. Okay, and print the character, so percentile d, that percentile c, okay, percentile c, and this is str of I. So let's see what we are getting. You can see we are getting this
Yes, sir.
hello.
Zero use, sir, in case of delimiter, sir.
Yes,
Why is here zero use, sir? Delimiter zero.
this is also an array, na? So this is also an array, only one character is there. So this is also we are representing as a string, but this string contain only one single character, so that character will come at the 0th index of array. So we are reading that character. Okay.
Yes.
Hmm. So in our question also you can see we are just reading this delim as a string. So you can see this is also a string, but we are storing only one character, that comma or anything. We are just representing by this, and this is str is also a string. Both are actually an array of the characters. So to just uh, read the this delimiter actually comma, okay, so we are using this 0 index, so that will come at the 0 index. If second character is there, so that will come at the 1 index. So you can see now we are breaking this strings by the separated by the comma, and here we are not using any shortcut function. So that STL library actually provides this shortcut function. So as I see here, this str took that also breaks the strings by some delimiter, but this is difficult to understand. So you can use your basic method, just traverse the array and just break the string. Okay, so that we have discussed here. You can also try this, and this is given in our notes, and you can try this how it is working. So otherwise, this is the simple method. We are just checking character by character. If any time our character is matched, so that means we are matching H, E, L, L, O. If our character is not matched with this delimiter, so that we are just printing that character. At any point, if this delimiter is messed, so we are just moving to the next line. So that means our new word will be printed into the next line. Okay, so in this way you can break solve this. Is this clear?
Yes, sir.
Okay. Okay. Any other query? Anyone?
Yes,
Yes.
sir.
Yes. Varun.
Uh, to like yesterday, we received a message in our
Hmm. OPP.
dashboard. Yes, sir. About
So that
discrepancies.
yeah, actually that qualifier, you are qualifier student, no?
No,
No.
sir. I am term.
Okay, so I think ES have some just delay in the score releasing, so they are just working on that. Operation team are working on that. So maybe you will get a score maybe in next 1 2 days.
No, sir. I think I got the score, but will the score be displayed as programming quiz one, sir? Is that the
Yes,
OPP?
yes, yes. That programming quiz one.
Okay, sir.
That is
Thanks.
the score. So yes, term student score have, I think, released. That ES qualifier students, I think, have not released yet. So you will get soon. Okay. Okay. So any other
Sir, please
doubt?
explain the last, sir, that is test 26.
Sorry, your voice is
Test
very low.
26.
26. I'm not getting what you are saying. Yeah, Hemant.
Yes, sir, now got it, sir, got it. Regarding the last word got, na, test 26 output in the previous example.
This
Yes,
one.
got it.
Got it.
Yes, yes, got it.
Okay. 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 So then there is no query. Then moves to the content of week 8 and then week 9. So here, this is week. Okay. Hmm. So in week 8, you have seen this array data structure now in the previous week 7. Now array is just provide store the data that actually is the homogeneous. That means all data are same. Okay, same data type. If we are storing the integer, then we can only store the integer value in the array. But what happen in real life? Sometimes we need the data in grouped manner. Okay, so that suppose we are maintaining the record for students of our class, where we want to store the name of the students, we want to store the that branch or any specific information related to that student, and we will also want to store the marks of the students. So that means we are storing the information of each students, and that information may contain different data types value. Okay, so name is a string value. Age, if we are storing the age value, that is actually an integer value. If we are storing the marks also, so that may be a float value. And all these values should be stored in grouped manner, so that we are saying that this is a record. Okay, this is the record of each student. So that means this information are related to a particular one student, so that should be stored in the grouped manner. Okay, so how we can do that type of that processing, or that how we can store that type of information in our C programming? So that we can do with this user defined data types. Okay, so we can design this data types, and we can define that what type of information we want to store in the grouped manner. So that is called as a user defined data types, because we can design the structure of this data structure. Okay, so there is first is that structure. So the first is this structure, and you can see the definition. Structure is a C user defined data type that allow grouping together variables of different data types under one name. Okay, so we can give the one name to the structure, and inside this structure we can store multiple data types of value that will represent the different information for a particular entity. So here, say what is the syntax for this data structure is that we will write, this is a structure. Okay, so we will write this struct keyword for this, and then we can give any name for this structure name. So here you can give any name according to your that requirement. Suppose if you are storing the student information, so you can just give a name struct in student info. Okay, student info. Inside this, you can start this open bracket, curly bracket, and this is the close bracket, and then colon. And inside this you can define this that attributes of that students, which information you want to store. Okay, so you want to store the information related to the students, so like student name, student age, student course, student marks, or anything, student mobile number, or this type of information you can store. And this is the structure. So here data type, so this is simply a variable things. Okay, so variable type of things. So data type and variable name, then data type and then variable name too. And so this is called as a member of the structure. Okay, so member 1, member 2, and you can define any number of this member, and you that member may be a different data types. So in this way you can create a structure for that. So that means you are just creating a that view. So like you are storing a record, and in this record you are making it like this table. Okay, okay, so here this is the name, and this complete record we are just giving name like student info. Okay, and name, age, course, and marks, and other information like phone number and city. So like this information here, one complete row. Okay, so this is called as a row, will represent a one student complete information. So suppose some name of the one student is Amit, and the age of this is 25, and then course is C, and then marks is 50, then phone number is something, and city is anything. Okay, so like Delhi. Okay, so this complete information is referring to a one student, only this Amit. Okay, so similar type of information we can store for another student. Okay, so this is called as a record, and where the all information is stored in the grouped manner. So we are just designing this group structure, and this is called as a structure, and this is the syntax for that. And later we can perform some operation on this type of data. If we have this type of data, group data, then we can perform some operation on that. Suppose we want to figure out that what is the name of a student who have the highest marks in C. Okay, so this is one type of query. What is the student who have the lowest marks, how many students who have the 50 marks. So this type of questions may be asked for this type of records. Okay, so how many students belongs to the city Delhi? How many students who have the more than 25 A's, and what are the name of that these students? So this type of many query may be asked for this type of group data. And so because of that, this is very common in real life to just manipulating of this type of data. So in C we can just create this structure for that to store this type of information. And inside this is one example you can see. Here we are just creating a structure for student. Inside this we are maintaining three information for student: name, this is a string, okay, and age, this is integer value, and marks, float value. Okay, so this is just an example for one structure. And inside this, uh, now we can create a one variable for this structure. So this is just a structure for that memory. Okay, so we are just creating a memory structure, and after that we can create a variable for that, like integer a. So int a we are just creating. So we know that this is a data type, and this is also a data type, and which we have actually user have defined. Okay, and we can also create the variable for that data type. Okay, and the what is the name of that data type is a student. This is student. So we can also create a variable. So variable is just a, we will write this like struct student. Okay, so this is now representing a data type place. And this s1, now this s1 is a variable name, and the name, that data type of this s1 is struct student. So this struct student is now the structure of this s1. And when we are declaring this s1, so by default this s1 is pointing to three memory locations. So three memory location we will get for this. So this like this is name. Okay, so this is name, and this is an actually array of 50 elements. 50 elements, and this is just a 4 byte for integer information. This is referring to age, and this is a float memory location. So what is the size required for float? That is representing marks. Yeah, someone have raised the hand. Please open your mic and ask.
Sir, in the first case, sir, that is students, struct student, sir.
Haha.
Here, student acts as a name of the variable name
Ha.
or variable, no?
Which
Struct
one? This
student.
name. This name.
No, no,
Yeah.
no.
This.
Struct student.
Huh.
Struct student initially. The struct is
Yes.
a data type.
Yes.
The student is the variable. It
No,
acts like
student is not a variable. This complete one, struct student. This is just a data type like this. So this complete we are writing here.
it's
Okay.
totally data type.
Yeah, we are writing completely this struct student. There is one another way also. We can completely just give some name for this struct data type, and then we can declare based on that. That we can use with type diff. So that I'll discuss later. Okay. But
Sir,
here, yes.
sir, if we consider struct student S1, so struct student is a data type and S1 is the variable. Okay,
Yes,
sir?
this S1 is a variable.
Okay. But
Okay.
if we consider struct student only in the upper case, above case,
Huh.
in that case, sir, struct student is variable and struct is data type, na? Or what we
No,
say,
no,
sir?
no, no. This there should be a complete syntax. So if you are writing just struct student, okay, so like this. So this is not a correct syntax because struct student, that means you are trying to create a student structure. So that means body is also required. Okay, so here above we have written this struct student, and after that open bracket close bracket. So this is just a definition of a structure. We are just defining the structure. After defining the structure, you can create a variable for that structure. So S1, S2, S3, you can create any number of variable for that structure, and each variable will point three memory location. One is for name, second is for age, third is for marks. Okay, so this you can access three member. So you can see these three members we have defined for the structure student. You can access these three member that memory locations with the help of this S1 using the dot operator. So that means you can just store the name using this s dot s1 dot name. Okay, so this will point to this memory. This is an array. Okay, if you are writing s1 dot age, so this will point to this second memory location, and this s1 dot marks, this will point to the third this marks memory. Okay, so this complete new memory allocation will be happen when you create the variable for this structure s1. So this new memory, and when you create the another variable same for the same structure, like you can also write like struct student s2. Okay, now s2, so same, this is just a structure, or we can say that blueprint. Okay, so you will get a different memory. You will get a different memory with three partition. Okay, same, the first part is an just array of the 50 blocks. Okay, and this part is just a integer size, this is a float size. Okay, this is the complete new memory location. So s2, you can store all the name information here. S2 dot age you can store here. S3 dot a float you can store here. So this memory is actually provided in the grouped format. When you are creating any object, that variable s1 for structure student, you will get a group memory. Okay, where you can directly access the name, age, and marks from that memory. If you create the second variable, you will get another group memory. Okay, where you can access all these three information for that. So in this way, this we are storing this information, name, age, and marks for each variable which is declared for this structure student in the group manner, and we can store this and we can later use this. So you can see we use the dot operator if we have declared this variable with the help as a data type of struct student. Okay, so you can see s1 dot name. We want to store the name. We are using s1 dot name, and if we are storing the age, so s1 dot age, s1 dot marks. All information will stored here. And here, what are the memory allocation happen actually? So here, when we create the one variable for that, so what is the total size of this? So name, we have 50 characters. Okay, so 50 byte. Integer is 4 byte, and marks. Okay, so that marks also, that float. What is the size of float? That combined memory will be allocated. Okay, what are the combined memory which we have for each data type? We will add all the memories, and that memory will be allocated to the variable combined memory. That means sum of each memory that member size. Okay, so that memory allocation will happen, and you can store this information in group manner, and later you can simply print also. So you can, with using this dot operator, s1 dot name, s1 dot age, s1 dot marks, you can print also this. So this is the structure, and this is dot operator. Now second, user defined data types is union. This is union. Okay, and union is also very similar. Now you can see we have just changed this union keyword. Otherwise all the things are looking same. Okay, union keyword, and this is the name of the union, and after that we can define this data type member 1, member 2, like this, similar to your structure. But what is the difference in between? So a union in C is a user defined data type that allow storing different data types in the same memory location. So here what happening actually, in the previous structure, we are getting the memory of the that sum of each member, sum of each member size. Okay, so we are getting that memory. So here 50 plus like 4, and suppose float is taking 4 byte, so that means 58. Okay, but here in this union case, memory is allocated to for the largest member, largest size member. Suppose the member 1 is a that integer. Okay, so integer, and second is like a that char, single char, and third member is just like a str, and that is like 20. Okay, so this type of, suppose we have multiple members, so memory will be allocated for the largest size. What, which member have the largest size, that memory will be allocated for this union. Okay, and you can store the one value at a time, for one member value at a time. You can also store a multiple member value, but you may get an error for some times, because if that size of the each member is getting more than the largest size. Suppose I am giving the example. Suppose you have a multiple variable like this, int a and int b. Okay, and we have the one double. Okay, c, and like we have int d. Okay, so which variable have the largest size here? So all integer are 4 byte, double have 8 byte. So only 8 byte memory will be allocated for this union. Okay, 8 byte memory will be allocated. At a time you can store the one value. Either you can store the value for a, or you can store the value for b, or you can store the value for double c, or you can store the value of d. Okay, but so then this will work fine, because largest size is 8. You can, this size can also store the smaller variable value like integer a, b, and d, and this can also store the value of for double c. But if you are just storing value for a, b, and d, so total size you are getting, that means 4 4 4 12. Okay, in that case maybe you will get some that error, or maybe you will get some randomized behavior of the code, because this union is actually to store one member value at a time. This is the purpose for this union. You can define different data types inside this union, but at a time just use one member to store the value. So this is the structure. So unlike a structure where each member has its own memory location, all members of a union share a share memory location. So you can see here we have the share memory location for uh, all members. So that means this 8 byte is provided for this union, and all will use the same memory location. Okay, because of that, at a time one member value should be stored for the correct implementation. So sometimes uh, when you have a chance like that, if you are getting a value and that value may be a different types, okay, so like that may be a integer value, that may be a float value, that may be a strings value, that may be character value, and you are not sure that which type of value you will get. Okay, so you can define this union by some name, and you can store the value based on that what type of value you are getting. Okay, so you can see here in this example we have just defined the union value. Inside this we have defined the member, int value, float value, string value. So any variable which we have declared later union value v, so for v, if we are getting integer value to store, so we will use the int value member for this, and then we will use this. Okay, and later if we want to change this, we want to store the different value, so this v dot float value we are updating this, so this value will be stored. And sometimes if you want to store the for the same variable, if you want to store string values, then you can store string value for the same variable. So this is the purpose of union.
Sir, sir, please explain once again, sir. Yes, sir.
Aha. So suppose you have the so union, there is a common concept is union actually all member actually use the shared memory location. Okay, all member use the shared memory location. So here you can define any number of members, but the memory allocation will be happen for largest size member. So here you can see we have three variable for this value, that int value, float value, and string value. So this is the largest size member. Okay, so 20, float taking 4, integer taking 4. So one memory will be allocated for this structure, and that memory size will be the 20 byte. Okay, and this is the common memory. You can store the member value for first variable, so that will also store this memory location. Okay, if you are storing the value for second member, that will also be stored in the same memory location, so this will be overwrite. So first value will be removed and second value will be stored. If you want to store the string value, so that will also be stored in the same memory location. So that means each member are sharing common memory location here. Okay, so uh, this is the thing here, and structure we have the separate memory allocation for each member. So this is the difference between structure and union. And you can store any one value at a time for union. So if you are getting the data, so in this example if you are getting the data integer, for this we have declared the same way union value. So this is the union data type, and this v is representing a variable. Now for v, you can store a integer value also with this member. You can store float value for this inside this. Okay, you have to change the member name, float value, and you can use the string also. You can also store the string. Okay, with the string value variable. So, but at a time you should store one member value. Okay, do not store three value. So you have three value, so do not store three value at a time. So maybe you will get some random value behavior. So maybe when you are when you will access the element, that member value later, you will get some random behavior if you are storing all three value at a time and you want to access all these. Okay, so just you store one value, and after when you are updating by the second, so there may be chance this value will be distorted or it will be lost. Okay, and when you are updating by second value by third value, so the previous value will be maybe corrupted or lost. Sometimes what happen, you will get the correct solution. Suppose here you have 20 bytes. Okay, so integer takes 4 bytes, float takes 4 bytes, and you are storing both value in this. So actually the both value will be stored because this have the enough space to store the both value. But you cannot store all three value at a time, because when you combine all these three value size, this will be the more than this 20 bytes. So in that case, you may get the error. So the purpose of union is just to store one member value at a time. Okay, where the data type of the each member may be different. So the that means in union variable you can store multiple data type of value, but at a time one value. Okay,
Yes, sir.
so
Thank
yeah. So and next is enum. So that enumerated types in C. This provide a symbolic representation to just maintain the code properly and readability, for the proper readability. And like this example you can see the syntax is very similar. You can just give the keyword enum and then give the enum name. After that you can give some symbolic name or label. You can just define like this: enumerator 1, enumerator 2, and like this, and you can define. And by default some value is assigned actually for each that one integer value. Okay, one integer value assigned for each label. So instead of just storing the value of integer form or you in the in like this form, uh, you can give simple label name. Like in the lower example you can see uh, here. So in a month. Okay, now month we can represent, this is more actually clear data. Okay, jan, feb, march. Instead of writing 1 2 3 4 5, so sometimes we are asking that what is the month of seventh month. So that 7 is not clear in the code, what is the month of 7. So instead of that we can give the label for that 7 value. Okay, so label for 1 we are giving this name jan, and in our program we will directly use this jan label. Okay, this is not a string. This is not a string because string can be written inside this double quote, but this is not written inside this double quote or single quote. Okay, this is just a symbolic that label that have just a equivalent integer value also. Okay, but in code we will directly use this instead of the integer value. If you not assign this any value, so jan to 1, by default it will assign to 0 initially. So 0 is the first value. By default this fab will become a 1. So suppose if you are not writing this statement and just writing jan comma fab comma like this, so first value will be assigned equivalent to a integer 0. Okay, second value will be equivalent to a 1, then like 2, like this. Okay, if you assign the first value that jan equal to 1, then next value will be the next just incremented by the previous value. So if jan is equal to 1, then feb will automatically assign to 2. Okay, march automatically assigned to 3, in this way. So this is for just create a symbolic name for constant integer value that makes your code more readable and maintainable. Okay, so like this. So here you can see we are giving this name, and in later in the code we can just give in a month m1 m2, and we are just passing this value m1 equal to feb. So instead of writing m1 equal to 2, so 2 is not representing any thing. So we are not understanding that m1 equal to 2, what is the meaning of this. But here this is very clear, m1 equal to feb. This is clearly we can readable or understand that the month 1 is assigned to feb. Okay, and if you want to just print this value in the that in the with the specified d, you will get a corresponding that integer value. Okay, so you can use that you can just display this label in your code, and but that can be used, that corresponding integer value can be used for the manipulation in the code. So like if you are using switch and case statement. Okay, so you can just pass this fab now this type of value, but you can write like this. So case 1, case 2, case 3. Okay, and inside the switch statement you are passing fab month. So this fab month by default automatically match with this case 2, because corresponding value of this integer value for this feb is with case 2, that 2 integers. So that 2 will be matched with this, and that operation will be performed. So this is just for a readability or maintainability. You can give some name for some integer value. So this is very common when you are providing some specific options to select. So like when you fill any form for any application, so you have sometimes you have just some option are given and you can select those option only, and some value are given actually in that options, so you can select. So same here, that enum you can represent the option with some label, and corresponding integer value you can use in your code. Okay, so this is the enum data structure that we have. So these three user defined data structure we have learned in week 8, and we can also use this structure with the help of pointer. So that means structure pointer. Yeah, one thing I have left. So that structure can also be we can change the data type. So here you can see we have defined this structure name, and we are also declaring this variable with the help of struct student. What you can do, you can define the type diff using the type diff. You can change the uh, structure name, the complete name. What you can do, you can write like this. So type def type diff, and after that you can write this struct student, and you can just give a new names like st. Okay, so this is the syntax. Type diff, we are defining the type for this structure struct student to this st. Okay, and later you can define any variable with the help of this st. So like st that s1, like this. So now this become a data type for this structure. So you can define the name for any structure like this. Okay, so you can just sort the data type. Okay, no need to write the complete struct student every time. You can just define the type in sort st, and later you can define any variable with the help of this st s1. Okay, so this is the defining of data type. For any structure you can define, or any union or enum you can define. So this is about structure, and now we can also use this structure with the pointer representation. Okay, so point, this is not, okay, this is example actually, not pointer. Okay, these are some example which are given based on that. So you can see this document I have uploaded in the supplementary content. So another is the pointer representation. So pointer representation, here I have seen that you are accessing this variable with the help of dot pointer. Okay, so using that s1 dot name, s1 dot age, like this. But if you have the pointer for any structure, okay, suppose if you have declared the pointer for any structure, then you have to represent you can access by some different way. So like this example. So lower one, okay, this one student. Okay, and we have suppose defined the struct student st. Now we are declaring some pointer for that, so we will write like st asterisk ptr. Okay, ptr. So we are defining a pointer of structure data type. If this is a pointer, if we have the pointer for any structure, then we can access the member with the help of this symbol. So ptr and dash, and then greater than sign. Okay, then name. Okay, then you cannot use the dot operator. You can access the member with the help of this ptr. This looks like arrow, but this is not an arrow. So this is just a dash and greater than sign. Okay, and then you can write ptr dash this arrow and name, and ptr this arrow dot age, this ptr dot arrow that marks, like this. Okay, you can access all the member with the help of this if you have the pointer of your structure. This is an variable, and this is the representation of a pointer for the that structure. So this is the way you can access the variables. So this is also important for the end-term exam questions. So this type of question is asked in the previous exam. So if you have pointer for a structure, so how you can, which one is the correct representation to access the member, like this. Okay, so these are the very small things you can note down. Okay, so now this is about the structure. Yeah, any query in this B8 topics. So these are the three main topics which are discussed in week 8, and problems are based on that. Okay, so later examples are given, so you can also read, see this example. So inventory management, where we are using this books record, toy records, and day of the week. So some examples are given with the explanation. You can see this. Now move to the, yeah, any query in this week 8?
Sir, pointer little bit more connected regarding
Pointer topic. You're talking about the pointer completely topic, or just regarding this structure?
regarding the structure, sir.
Okay.
Pointer means simply it denotes to address of a variable.
So that is actually okay. So I'm just giving one example. Okay, so I'm writing one code here. So we can define the structure. Uh, so like struct and student inside this, and we will use this semicolon. And here we will just define some name. So like int id. Okay, and int, sorry, not int, scare name, like we are giving 30, and or yes. So I'm just using these three variable, and id name, and this. Okay, and what we can do, we can define the name. So like this is the main function. So type diff, sorry, type diff, and we will give the struct student completely here. So this is, and then we are giving the st, this. Okay, now so this is the sort data type name I have defined here. So now I can declare the variable like st equal to s1. So now this is the variable declared for this structure student, and I can assign the value like this s1 uh, dot. Okay, so here we are using this dot operator. So s1 dot that id I am assigning like 1001, and now s1 dot name. So here this is an array, so we are assigning some value. So like that Amit. Okay, and we cannot assign like this. Wait, no, we cannot. Not copy. Or but what we can do, we can write like this. So actually this is a string, so that a, no, in the code actually, sorry, dot copy. It's a dot not dot student dot cpy math. And let me just check the documentation was, copy the strings. So we can just check at cpy copy. We can read the value for that from the input. What to, if you want to store the value for this member, so we have to use this strcpy destination name, and then okay. So we can do in the code, so like So care name, so like this equal to Amit. Okay, now this is the value, but now after that we can use like this. So strcpy, and first thing is s1 dot id, sorry, name, and comma name. Okay, and third is that s1 dot that age equal to, we can directly assign this like 25. So these value actually we have here. So we have assigned the id, and we have copy actually. We cannot directly copy the string, so we can copy the string like this. So name, this is the string name we have with the Amit, and we are copying this string with the another string. So this str dot name. Okay, so this is just a variable, so we can print this all information with the using of dot operator. So printf, and inside this we can use this %ld for that s1 dot name, so s1 dot id, and now let's write the complete three print statement. Then this is the name, and next is age, and regarding this name we will use s. Okay, now if we run this, you can see we are getting this 1001 all information using /n. Okay, we are getting this information with the using a dot operator. But if we have the pointer of a structure, so like we can create a pointer, so that we have pointer that of type that st. Okay, and this pointer is like a asterisk ptr, and this contains the uh, address of for this sorry, equal to end of that s1. Okay, so now this is the pointer declaration. We have declared the one pointer ptr that contain the address of a variable of that structure data type. Okay, that is structure student data type. So now if we want to access the member through this pointer ptr, so we cannot use like write like this. Okay, ptr dot id. Okay, so now this is the incorrect representation. So ptr name, and here ptr at age. Okay, so we cannot access using the dot, so we will use this dash and this greater than, this representation here, and same this one. Okay, and this is the next. Now we will get the same information. So if you have the variable of the structure, you can use the dot operator to access the member. If you have the pointer for any structure variable, okay, then you use this dash and greater than to access the member. So pt pointer and use this operator, then you can access all the member for this student as well. Okay, so in this way you can store the information with the one name. Okay, so this s1 is just a one name, that means it is referring to the one student information, so that contain the all attributes, that id, name, age. Okay, so in
Sir,
this way,
here,
yes.
sir, here for uh, any other student S2, S3, sir, what
Hmm.
we have to do, sir?
So you have to declare the another variable s2, s3 like this. Okay. Suppose if you have 100 students, then is this the correct way to declare the 100 that variables? So what you can do, you can create an array. That array type will be the structure data types. So that means if you want to store the 100 student information, what you can do, you can declare an array like this. So st, okay, and st you can give the name like record, okay, and just give the size 100. So here, now the type of this is this is an array. Record is an array of 100 elements, where each element is a variable for the that student data type. So here the record. So that means you can store the information record like 0. So this is referring a first student. You can access all the member, like you can see all member are coming. So age, ID, name. So now you have the, you can store all the 100 student data. So record 0, record 1, record 2, record 3, like this, using the index. In this way you can store the of the all, if you have the multi more data. Okay. So now this st is working as a data type. So like int record 100, same you can declare as a st record 100. Now this each in that index is referring to a one structure variable. Okay. So
Yes.
you can do all this type of operation. You can use store multiple records with the help of this array. So this is structure, all about the structure pointer I have discussed. Okay. Now let's move to the Week-9. So that Week-9 is a dynamic memory allocation and 2D array. So these topics are discussed in Week-9. So dynamic, what is dynamic memory allocation? That we will discuss this thing. So dynamic memory allocation and static memory allocation. There are two terms actually we have. So static memory allocation is when we write a that when we are writing any code, okay, and we have pre-declared that, like we are using any integer a, okay, and we are using this in a in our program, and we have suppose declare int a arr and 100. So that means we are predefining the size. Okay, so here we are declaring a single variable, and this variable will memory will be allocated for this variable 4 byte. Okay, and in our program we have declared arr 100, and each element is integer, so that means 400 byte will be allocated at the compile time. So there are two phases when we are running our program. First is compiling, okay, compiling, and then we are running. Okay, so first our program is compiling. So at the compile time, all these memories actually allocated to our variables. Okay, when our program compiles, so at that time memory will be allocated, that fixed memory. This memory is fixed. Okay, so that means 4 byte will be allocated for this a, 400 byte will be allocated for this arr, and this memory is fixed, allocated at the compile time. And whenever your program is running, actually at that time you can use this memory, you cannot change the size of the memory, because this memory is allocated at the compile time. Okay, and at the running time you can only use this memory which is allocated to you. You cannot resize the memory. So this is called as a static memory allocation, which is allocated at the compile time when your program is compiling, and you cannot change later when your program is running. But this is the second concept, we have dynamic memory allocation. So that means this memory allocation we will allocate at the run time, not the compile time. So that means we will not allocate memory at the compile time. When our program is running, at that time we will pass the request, and that will allocated memory on the running time. Okay, what memory we need at the running time, we will pass this request, and that memory will be allocated at the runtime. Okay, so there are some problems when we don't know what are the required size we need to allocate. Okay, so suppose if you are writing a program and you don't know what are the required input you have initially. So, okay, so if you are writing the code, and initially you don't know what will be the size of the input for your code. So that you what you can do, you can just use the dynamic memory allocation feature of the C. At the running time you can decide how much memory you need. At that time memory will be allocated to you. So that is called as a dynamic memory allocation. And at the same running time you can also release the memory. Okay, you will just request the memory, and then memory will be allocated to you at the running time. And after you can use that memory, and later you can release that memory. Okay, so same all these operations you can do on the running when your program is running. Okay, so that is called as a dynamic memory allocation, and this C programming provides this feature that how you can do the dynamic memory allocation at the runtime. So there are multiple things. Suppose if you are just if you are writing a shopping cart application where someone is purchased any number of item like 100 items, and you are just adding the cost of that 100 items in your program, but you don't know how many items can come for any customer. Okay, so someone maybe purchase 500 item, so you can decide, you can allocate the memory at runtime, so that if uh, you are getting multiple items continuously, you can allocate the new memory and just store the information. So this type of example where you don't know initially what memory you will need at the runtime, so at that time this dynamic memory allocation features actually useful. So there are some function actually C provide for this dynamic memory allocation, that are actually, first is malloc. Okay, there are basically four function. I'm just giving the name malloc. Second is calloc. Okay, and third is realloc, and fourth is free. Okay, free. So these are four memory allocation function C provides. Here malloc and calloc are approx same. So you can use either malloc or calloc. There are some difference then that we will discuss. And okay, so now just discuss one by one. So how we can use this malloc function? So purpose, you can see, allocate a single block of memory of specified size in bytes. This malloc is actually allocate the single block of memory. Okay, and what return type? So actually we are so this malloc function that allocates some memory, and that memory that after allocation, that program will return a address actually of that memory, so you can use that. Okay, so what is the syntax for this? So syntax, you can see, uh, we will write this, so just we will consider this one, this side. Okay, so this is the malloc. Okay, malloc, and we will pass a single value, so this single parameter, and that represent the size of the memory. Okay, you can simply write like, if you know the calculation, if you need a 10 element of integer size, okay, so 10 into 4 is actually a that 40. You can directly pass 40 inside this malloc function. Okay, malloc inside the bracket 40. So 40 byte memory block, actually complete 40 byte memory block will be allocated at the runtime. Okay, but that return type, what will be the return type of this function? So you have already seen that if we are writing any function, so function maybe return something, or sometimes not return anything. Okay, but this function actually return an address actually. Okay, and the address type is actually by default void asterisk. Okay, so after memory allocation, this function return an address of this void type, none type. Okay, but we want to use this memory for some specific purpose. Suppose we want to store the integer element inside this, so we will just create a pointer. So this is an pointer, int asterisk. Okay, int asterisk pointer numbers. Okay, int asterisk number. So this number is a pointer that will contain a address of a memory that will contain the integer elements. Okay, but this memory allocation is providing a void type address, so you have to use the typecasting to convert that address into a integer pointer address. So this is the typecasting. That means you want to use this memory block as a for the integer elements, to store the integer elements. So you have to change the type of return value, that you have to use the typecasting. This is the typecasting way. Okay, int asterisk. So that address will be converted into a integer pointer address. Now that address will be allocated to this number, and this is now integer address, so that means this will be separated. That means you can store the 4 byte one element, so integer element, so 444 byte you can use this to store. Okay, if you are using the integer pointer for this after typecasting. So 4 byte it will be separated. So you can use this memory at the runtime, and you can free this memory after the use. So this is the malloc function. So let's just explain this in the code. Now, so I'm just reading one value. So like int n, okay, and this n we are not declaring anything. So we will read the value for this. So scanf at the runtime. So %ld, okay, and the value for n. So this n we are taking for the number of elements. Okay, how many elements we want to store. So this is n. Uh, After that we will allocate the memory. So you can see we are not creating any array or anything. So now we will create the memory. So like we will create a pointer. So int ptr, and we will write this function. So malloc, and we will pass the size. So we want to store the integer element. So n, that n into that size. If you don't know the type, that don't know the data type size, you can just use this size of, okay, and int. Now this is the function. So this malloc function actually return a, that you can see this comment what coming, type void asterisk. Okay, so you have to use the typecasting for this. So you will use this int asterisk for typecasting. Now this is become okay. So what this is coming, and stick declare library function. Okay, so malloc, yeah, we need one library for this. So that actually a standard library that has include std lib.h. Okay, so this malloc function is defined inside this library. Malloc, allog, all these functions are defined inside this. After you can see we have this function is written inside the code, and when this instruction will execute at the runtime, at that time memory will be allocated, and that memory we can use with the help of this ptr. And you can see we will store the other elements like this. So for we will run a loop. So we have now n element space by this malloc function. So we will run a loop. So int I equal to 0. So same, if we have the, so this memory is actually continuous memory allocation. So we can use this like as an array. So I is less than equal to less than n, and I plus plus. Okay, so now inside this we can store the, we can read the element scanf and %ld and %ld, and inside here that we will write this ptr. Okay, so ptr, and we can use the this, sorry, I. Okay, so what it is showing, okay, this end. Okay, now we are reading the element. You can see we are reading the n elements, and now later we can print the elements. So we will just use the same loop and we will print the element. So print f, and then by the same pointer, so ptr. Okay, and just use the slash n or space. Okay, so now this is the loop, this is the program with the help of the malloc function. You can see we are passing this size. So n elements we are reading at the running time. When after reading the n value, then we are passing this n value with this malloc function, and this malloc will provide the memory for this pointer, and then we will use this memory allocation here. And after using this, we will free this. So free, and just pass this ptr. Okay, so now this memory will be released. So we will write the return statement, return 0. So now this is the last. So here if we run this code, this will ask a element. So suppose we are passing the 5. After that we can pass this like 1, and enter 3, 5, 6, 7. Okay, now you can see we are all the data is stored 1, 3, 5, 6, 7. So we are reading the input, we are storing at the allocated place, memory allocated, that allocation happen at this instruction, and that memory place we are accessing by this pointer, and we are storing our data. Okay, and later we are just printing that data from our memory locations. So you can see 13567 is now printed from that, and we are just releasing this memory free bit here. Okay, now this memory will be released. So yes, please ask your query.
Sir, one doubt is there, small doubt. Here, the statement, sir,
Mhm.
in asterisk size of int, okay? Suppose size of int means here automatic takes how
Four.
many bytes here?
Four.
Four.
So what our machine is actually that using for integers, that is dependent on the machine. So this is not a fix. So what our machine is actually required for the integer, that size will be allocated here by this
Okay,
size of
whatever
function.
size it is, sir. Suppose
Yes, yes,
it is suppose 4 bytes into 5 digits, sir. Five
yes.
numbers. So
20.
20. Okay.
Hmm.
And so malloc is 20 means what? That is integer type, na, sir.
No, 20 bytes will be allocated.
Okay, 20 bytes number. Okay. Then
This is
what this
this is the
integer
size
actually
actually,
indicates?
total size. After that, that 20 bytes we will use to store the integer value. So that means 4 byte. Our every element will be occupy the 4 byte in this memory. Okay, so like here, so what will happen? This malloc function will provide a one block of if we are using for 5 elements, so that means 20 bytes. Okay, so this is the complete size of this memory block. But now when we are using the when we are changing the typecasting for this memory block, and so it become our pointer will access, so our pointer uh, after typecasting into the integer, so int asterisk, so our pointer is now integer, so that pointer will read as a 4 byte first. Okay, and it will store integer element. When we will increment our pointer to the one position to the next, so that will move to the second 4 byte. Okay, next 4 byte we will store our data. So now our pointer will access 4 byte in our in this block, and we will store our each integer value in each 4 byte location. If we are using character pointer characteristic ptr, so then we will just that use the typecasting care for this. So care asterisk and like malloc function. Okay, like this malloc. So this our pointer now will access one point, that one byte. Okay, so one byte, then second byte, then third byte, then fourth byte, like say. So this is our character pointer will read one byte. Okay, if we will increment our pointer, then it will move to the second byte. So one character will store at this location, then third byte. Here our character is now that our pointer is moving to 4 byte to the when we are incrementing one position. Okay, it is moving to the 4 byte. That means after so that 4 byte is taking for one integer, then our pointer will move to the second next 4 byte. Okay, so our memory block will be used for a that 4 byte blocks if we are using the integer pointer for that. Okay,
Sir, here before pointer that is int is given and before malloc int is given. Okay, so the type should be same on both sides, na, sir? Should be same, na?
uh, you are saying about this before and
Yes,
this
this the data of malloc is typecasted to integer type.
ha,
4 bytes
this
will
one,
be
this one.
divided.
Actually, this
Uh,
type casting should be the same of the pointer type.
always should be same, na?
Yes, yes. If your pointer is actually a integer pointer, so your return address should be typecast into a integer point address. That integer pointer address. By default, this malloc function return a address in the form of void pointer.
What's the white pointer, na?
Void pointer. That means it is just a one data type for the null none value actually. So not by default it is written as a that void pointer, but we will typecast into a integer pointer that address. Okay, so that it will be used as a integer that 4 byte blocks. If we want to access one byte. So then we have to typecast this into a character. So that care here and care same we have to write here care. Okay. So now
Yes.
you will move to a one byte data when you are using this indexing. So here you can see that we are using the indexing. So I equal to 0. So 0 means you are at actually first that first memory address. But when we are just writing a 1, so you will move to a 4 byte. Then that means from the fifth byte, fifth, sixth, seventh, eighth. That way you are just accessing. If your pointer is integer, if your pointer is character, so that means I0 is representing the first byte, I1 will be represent to the first that second byte. That means one byte difference.
Sir, here for every type, that is integer type or character type, sir, like we have written here I less than n. So this will be changed now or will remain fixed, sir. I less than n.
No, and we have written because we are just we are storing the integer value, and that n is representing the number of elements which we want to store. And based on the that information, we have allocated the memory. Okay, so because of that, we are using n. If you know that how many characters you want to store, suppose okay, so just forget this, and I am just writing like 50 value here. Okay, so 50 value. So here no meaning of this n anything. Okay, so or this 450 is not will divide into the by the 4 equally. So what we can take like okay,
40,
just
sir.
40 is not the good value. Yeah, so we can directly allocate this memory, but now you don't know what is the value of n. So here you should know at the time what actually how much memory you are allocating, that you should know. So accordingly you can access the elements. So suppose if you are using this integer, then at that time you have to written here like this 10. Okay, so 10 elements are actually required. But suppose if you are using as a that character, so that character you have to write here, same care you have to write here. Okay, now you have to write you can access the 40 different memory block. So like 40. Okay, so that means your loop will run that you will allocate a 40 index. That ptr size is now 40 characters. You have total 40 index for this because each index is representing 1 byte in this. But if you are taking for that integer, then now each index is accessing the 4 byte. So that means you have only 10 space in your array or this memory space. So like this integer. Now you cannot access. Sorry, I have written wrong.
So here we have to write 10.
Sorry, ptr, and this is integer. Huh. So that means this 40 bytes will be divided by 4. That means 10 element you can store of integer type. So you have to write 10 index for this.
Another
Okay.
doubt is this.
Hmm?
Yes, this is clear, sir. Sir, in the left side, sir, the asterisk is very near to pointer PTR, uh, but in the right side case, some cases, sir, that is very near to INT, sir. Could you please explain, sir? Is
No, no,
there any
I'm not
difference?
getting what things. Asterisk is near to.
Asterisk is appended near to PTR. Okay.
Uh-huh.
But in the right side, sir, or in I have seen several examples, it is appended to side like here int.
Uh-huh. So that not create any problem. Suppose if you write like this, it will work fine. So still it will work in the same behavior. So like 5 and then 1, then 2, then 3, then 4, then 5.
That is pointer type.
Oh, why this is okay? We have written. Sorry. Oh, we have to store more value ones. But we are printing only n times, so n value is by default last time 5, so it is taking that 5 value. No, it is reading 5 value here. Okay,
Yes.
okay, because here we have just allocated 40. Now we store this 10 value, but we are reading only 5 value. So you can see it is still working. So this is just a representation. More actually represent that both representation work fine. Okay, so no need to confuse about this. So that int stick, this is also fine. This is also fine. Okay, and same thing you can Also you can write like this. So stick, this will also work. You can see that compile is not showing any error. So this will also work in the same way. So like 5, then 1, then 2, then you can see you are getting the same. So this space is actually not affecting anything. So both are the same. Okay.
Sir, thank you.
Hmm. Okay. So one thing, more thing. Let me just discuss this. Here we are reading the value. Let's just skip this process. Okay. Let's see according to the concept what we will get. So let's write this in asterisk size of int, and let's run this. So that means 5, and after that we are getting 0. So here actually according to the C concepts, if we are using malloc function, so malloc function just provide a memory block, but it not initialize any value by default. Okay, so it not initialize the value of that memory places. It may be a random value you will get sometimes. Okay, but so this is according to the C standards and concept. But now our compiler is actually smarter, so they actually that initialize something here. So you will get most of the time 0. So like
Sir,
this,
here value means what, sir? What do you mean, sir?
you can see we have just allocate this memory for 10 place. Okay, now we are not storing any value for in this 10 place. Now we are printing directly. So there is a chance in the malloc allocation you will get some random value for this 10 place.
So by default, here 0 will be stored.
No, according to the malloc definition, actually malloc not initialize any value for the memory. But in these actually latest compiler actually that provides initialize something value. But according to the concept, malloc not initialize anything. So here you are getting 0 when we are running this like 20 times. You are getting all 0 place, but according to the concept this is not the correct information. Okay, you may get in some time you may get some random value here. Okay, here you are seeing this all 0 value, but there is a chance you may get some random value also. Okay, according to the malloc definition it provide the memory, but it not initialize any value to the memory block. So you may get any random value also in this all 20 place. But we have the another function calloc. Okay, so in the for the same purpose we can use calloc function. So now calloc function, now definition of the calloc is actually we can we need to pass two parameters. Okay, for the calloc function the purpose is same. We want to initialize yeah, so here actually similar to malloc but initialize all byte to 0. Here this is actually predefined for the calloc. Calloc will provide a blocks. Okay, that malloc provide a complete one block, but calloc provides a that n blocks. What size we are passing here actually, you can see we pass two parameters inside this calloc function. First parameter represent number of elements, and second parameter represent size of each element. Okay, so that means it will provide a that suppose if we have passing 20 number of elements, it will provide a 20 blocks memory that is actually continuous. Okay, previous malloc was providing a that one memory block, but it is now providing a that 20 blocks, and it will also initialize the 0 value for each block. This is the function of calloc. Okay, that is not performed by the malloc. You may get some random value in some case, but calloc case you will always initialize by the 0 all blocks. Okay, but here the two parameter we are passing, so this is the one difference with the malloc. Another difference is this calloc initialize all the bytes to 0. Okay, so Otherwise the all remaining things are the same. So per that syntax is actually very similar. So you can see calloc we are writing now. Instead of passing one parameter, we will pass two parameters, so comma. Okay, so this is representing number of element and this is representing size of int. Okay, what is the size of int? So now same things happen, you can use in the same way, you can access the store the element, you can print the element, and you will get the similar type of output here also 10, and this is 0 0. So this is guaranteed that if you are allocating the memory by calloc, you will always get this 0 initialization by this calloc function. Okay, but the previous malloc function, there is no guarantee for that. Okay, so now 10 memory is allocated of each of size 4 byte, and we will use this 4 byte by this pointer ptr in the same way, but all these blocks are initialized with 0. You will always get this 0. Okay, so this is the purpose of calloc. And free function we have already seen. After using this memory which we have allocated at the runtime, okay, so this function is actually executing at the runtime when our program is running. Okay, so this line is executing, this is executing, now this is executing. At that time memory is allocated and we are using that. But after using that this memory, just free it. Okay, if you feel that now there is no use of that memory, you can free, and you can just continue your program. Okay, so this is the just advantage of this dynamic memory allocation. You are allocating memory, you are just freeing the memory, and there is no need to initialize the memory at the initial time, at the compile time. So what happened actually, suppose there is one more drawback of the static memory allocation. Suppose if you initialize some size of your array, okay, you know that your maximum input will come like 1000 for the array. Okay, and you just initialize the size 2000. Okay, just more than that. And what happen if your input is coming very less, so like you are getting only 5 input, you have allocated that 2000 memory allocation, you have just defined 2000 memory size, but your input is coming only 5 element, 10 elements, so remaining all the memory locations are just wastage. You are not using that memory locations, but that is actually allocated to your program, and that is not are actually using by your program, so that is wastage. So this is the advantage of the dynamic memory allocation. At according to your need, you can allocate the size and use that, and once your use is completed, now just free it. Okay, so this actually saves your computer that RAM actually memory. So here you can see we want to store 5 element, just we are allocating the 5. Okay, and then we are freeing it. So it is only utilizing the required memory, allocating that required memory only. So this is also one advantage of dynamic memory allocation. Realloc is one more function that in this for function that is actually used to resize your memory. Okay, so suppose in this function you can see initially we have in that allocate some memory by our this malloc function or calloc function, so like 5 size of int. Okay, but in later program we need to add more elements in this. Okay, in this we want to store more element in this. Now this 5 is not enough for, so what we can do, we can reallocate the memory. So this realloc function we can pass. So same pointer we will use number. You can see number here. Now we will call this realloc function and we pass the numbers previous pointer. So this is pointing to the previous 5 elements, okay, which we have allocated previously. Now we are updating the size, total size. So that means 10 into size of int. So that means we are updating our size to from 5 to 10. So now previous size was 5. Now we are updating our size to 10. So that means the previous 5 elements and 5 will more add in this. Okay. So now this size is now incremented to total 10. And you can add more element later in this. So we are resizing our element. So what happened? There is one question here. So suppose this first memory allocation is happen at some one memory location. Okay, now suppose this is 1000 and we are using integer, so this is 1004. like this. So we have 5 element. And now this is the continuous memory allocation. Now later we have added 5 more. So is there any chance that we have the empty memory after this continuously? Okay, and then we are adding into the same memory location. But there is a chance that this memory is occupied by some other memory, other process or something. You have this continuous 5 memory space, but there is no space empty after that, but you want to add 5 more elements. So what will happen in this case? Total 10 memory blocks will be that continuous memory will allocate in some another place. Okay, total 10 memory blocks will be allocated at any another place. And these 5 elements, if any elements are stored at this location previously, that will be copied here. This first five. Okay, so remaining 5 will be come into the continuous memory locations. So if memory is available, then your memory will be allocated from this after this previous memory allocation. But if memory is not available after that, then totally new memory will be allocated and the previous element will be copied to that new memory allocation. So you there is no data loss. Your data will not be lost in by this function, realloc function. Okay, you will get a additional memory, then you can use that. So this realloc function you can use if you want to add more memory into your program at the runtime. And same things, you can deallocate the memory. So this is some examples given, so you can see this. We have just stored by the malloc function here. Okay, n size, n is 5 memory is allocated. Now we have stored the element. Okay, we have stored the element, and later we are now increasing the size. You can see we are increasing the size to 10, and again we are allocating the memory data for that remaining size. Okay, so in that way you can use this realloc function. So these are 4 functions actually used for the dynamic memory allocation. So you can see some example for this also. So we have okay, so examples are given, but you can use this memory allocation. You can just explore this, and we have asked some assignment question on this also, so you can check. Okay, now this is also one important topic, 2D array in the Week-9, 2D array, and this is very common. There are many type of application, and very common is just like a that matrix. You know that matrix representation, row and column combination, column. Okay, R into C. So this type of data, if you want to store the data in matrix form, okay, where you have some row and you have some columns, and you want to store all the elements. Suppose if you have 3 by 3, so 3 by 3, that means 9 elements you want to store in this form, like 1 5 8 6 3 2 4 6 9. Okay, so this is index 0 1 2, this is index 0 1 2. So 2D array, that means you can define the row and column things, and accordingly you can store the 2D data, two-dimensional data, where 2 dimensions are there. So first is representing row and second is representing columns. So this type of data you can store with the help of 2D array, two-dimensional array, matrix data. Okay, so memory, how you can allocate, how you can that declare this array. So this is the syntax, data type. Okay, so what type of element you want to store, so that is actually data type. After that, array name, and then you have 2 brackets. First bracket is representing as the size of rows, and second bracket is representing size of columns. So how many number of columns, how many number of rows we have. So you can just declare the array like this. So this is representing 2D array. Now suppose this is just an example. So we have declared this board 3 3. Okay, so this is representing a number of rows and number of columns. So R and C, number of rows and number of columns. But indexing will start from 0. Okay, so 0 1 1 and 2 for rows, and same for 0 1 2 for columns. Okay, So indexing will always start from 0 in the array. So now this will, you will get an array of the two dimension form. So now 0, this is the index for row. Okay, so R, and this is the column 0, 1, and 2, and same 0, 1, 2. Now you can store the elements on these cross combinations. So like R00, you can store 1, 5, 8, 3, 2, 6, and 5, 9, 4. Okay, now that means this element is coming at this, suppose array name is A, so 0 and 0. Okay, this is the indexing for this first location. Okay, the what is the index for this is row and column combination. Okay, so 0 and 1, so 0, 1. So using this indexing, this first block is for row representation, second is for column representation. You can pass the index and you can access all the value. Same way you can store the value with this help. Okay, so now you can see the complete example for this. uh, hmm. So now this is just a compile time initialization. You can see 3 matrix 3 4. Now that means this matrix is allocated like 3 rows and column 4 column 0 1 2 and 0 1 2 3. Okay, so 4 columns. Now when we are declaring this first, so this is representing a first row, 0 row 0, and this is row 1, this is row 2. Okay, so that means this 1 2 3 4 will be allocated 1 2 3 4, then 5 6 7 8 5 6 7 8, now 9 10 11 12. So now all these will be stored at this way, and you can access or traversing these elements with the help of nested loop. Okay, so first loop you are running for to traverse the rows. Okay, and second, inside this loop you are traversing the columns, and you can access the element with the help of this array name and column index and row index and column index. Okay, so that this means I equal to 0, that means you are accessing this 0 row, and inside for this 0 row you are accessing all the columns. So that means inner loop will be referring to the columns number. So that means for single value of I, you will traverse all columns. A second. Hmm. Okay, so using this nested loop you can access all the elements. You can see we are adding all the elements, so we are traversing a row wise element. Okay, so for each row we are traversing all the column value and we are adding the all the value by this help. Okay, so this is row and this is j. So in this way you can traverse all the columns for each row. Okay, j1, and you will get a sum of each element. So finding maximum or minimum in the row, that matrix, so same things you can find, consider that max, the first index value array 0 0 is the maximum. After that you just use this nested loop and compare the element, each element array ij. If you are getting greater value of the previous value, just update this max value. So in this way you are traversing all the element in 2D matrix. Okay, and then you are figuring out the that maximum element by this nested loop. So 2D, that array 2D matrix we can access with the help of this two nested loop, and same way we can also store the element by this 2D nested loop. Okay, so these are some example, real life example games, 2D games. We have matrix, we have data analysis in the form of tables, we have image processing. Image is also represented by 2D pixels, 2D array pixels, so that also can be solved by this 2D array. And same things you can represent this 2D array with the help of dynamic memory allocation. So that means here we will create an array. So that means we first array we will create, and this array actually where the each value is representing to referring to another array like this. Okay, so that means this array is just a pointer, and this pointer is referring to another array of some elements. This is the another pointer, so 0, this is a 0 pointer, this is the 1 pointer, this is the second pointer, and each pointer is pointing to another to one dimensional array. So in this way you can also allocate memory two dimensional. This is also a two dimensional memory allocation. Okay, so that means you have multiple rows, 0 1 2 3. Okay, so matrix is also a collection of rows like this. So same way you can also do by the that dynamic memory allocation. So here you can see we are just taking one pointer A. Initially we are creating this size of an array, so that we are creating this array, and for each index of this array we are allocating the memory later. That, okay, 1 second. Oh, this is for 1D array, so this is single dimensional array, but for 2D array you can see we have the first array. So that first array we have created. Inside this array we will run a loop for each index, and for each index we will create another memory allocation. So this is referring to another, that means like this. So this a pointer, and this will allocate a new memory by this. Okay, so we are just creating a space like this, so that will also work as a 2D array. So you can see we will just use by the same indexing way, by nested loop, printing the element by nested loop, and in this way. Yeah, so this is the 2D array which is discussed. So there are multiple problems you will see for 2D array also. So like finding maximum, finding the sum of all elements, minimum element, and finding the all even elements, number of even elements in matrix, number of odd elements in the matrix. And this topic is also important for the OPP 2D array. Okay, so just practice with this 2D array with the help of nested loop. Okay, so these are the topics of week 9. We have any query in this, anyone? So
In
now
re-alloc, sir, what happens, sir? When if
realloc. So realloc function is basically if you want to resize. So we are allocating memory at the running time. Okay, suppose we have allocate 5 element memory, but later in the program we need to increment the size allocation. Okay, we need to add 5 more element in our memory, so we can resize our previous allocation. So that means our previous element will remain same. Okay, that if we have, suppose if we have stored 5 element previously, so that will remain in the memory, and we will add 5 more memory location into that with the help of realloc. So we can resize the allocation.
yes, sir, yes.
Okay, yeah. Okay, so this is week 9, and any other query, anyone? So I hope you have the session.
WTA question may be released, sir. That will be very useful, sir. And
Which
students.
question? Which question?
WTA, weekly time assignments.
That question will be released after completion of all timed assignment.
Okay, sir.
Okay. Okay. So I hope you have another session from 8 math session, I think. So if there is no query, then we can close the session. Okay then. Thanks. Thanks everyone.
Thank you, sir. Thank you.
Yeah. Good night.
Good night.
Thank you, sir.
Yeah. Sure.